Look at a simple map of the solar system and one region still feels unfinished. Mars circles the Sun as a small rocky world. Far beyond it, Jupiter dominates the outer system, but between them, where another planet seems as if it should belong, there is only a thin belt of fragments moving through the dark. That picture invites a fast answer. Maybe a planet formed there and was destroyed. But the mass ledger gets in the way almost immediately. Gather every asteroid in the main belt into one place, and you still would not have enough material to build anything close to a normal planet. The region looks large on the map, but what survives there now is surprisingly light. So what are we actually seeing in that gap between Mars and Jupiter? The remains of a lost world, or the record of a world that never finished forming? By the end of tonight, you will understand why the material between Mars and Jupiter failed to become a planet. The answer begins with one small number, and then widens into a much larger question about how planets are allowed to grow at all. If you enjoy exploring questions like this with me, subscribing to the channel helps others find them too. Sharing the video helps even more. Let's begin. The first wrong turn comes from trusting your eyes. The asteroid belt is wide, and width fools us into expecting abundance. On a diagram, the band wraps so far around the Sun that surely you think there must be a colossal amount of stuff packed in there. But spread is not the same as weight. Think of a warehouse in the dark. It feels full before anyone hits the lights. Then the lights come on, and the shelves turn out to be mostly bare. That is more or less what the belt becomes the moment you measure it. NASA's plain modern figure is blunt enough to reset the whole conversation before it really gets going. All the asteroids combined contain less mass than Earth's moon. I love that number because it embarrasses the easy myth so efficiently. The moon isn't anywhere close to planet-sized, so if the entire belt doesn't even add up to that, then the scene between Mars and Jupiter stops looking like the broken pieces of a normal planet and starts looking like a leftover that has already been picked nearly clean. Here is where the popular image digs in its heels. You can accept the number and still quietly keep the old picture running in the back of your mind. Maybe you think, there really was a planet out there once, and maybe nearly all of it got blasted into the dark. The trouble is that this rescue doesn't simplify anything. It just hands you a longer bill. Where did almost all the mass go? Why does the zone hold onto orbital structure, tied so precisely to Jupiter? Why do its biggest survivors carry such different internal histories, instead of looking like matching shards of a single broken body? The cinematic answer only sounds quick until you actually try to balance the books. The belt's largest residents make the problem worse, not better. Ceres is round, a small world pulled into a ball by its own gravity. Vesta is big enough to have kept a record of a hot interior and a battered surface. Pallas and Hygeia ride along on their own separate paths with their own quirks. This is not one neat shell cracked into pieces that would slot back together if you imagined the right disaster. It is a whole population. Every major body carries its own biography, and the population as a group sits inside a setting that looks edited rather than blown apart. It helps to set two pictures side by side. In the first, a finished rocky planet exists. Its gravity has hauled most of the nearby solid material into itself. The neighborhood has a clear winner, and everything else is either inside that winner or swept away. In the second picture, no single body ever reaches that kind of dominance. Plenty of objects keep circling. A few grow partway and stall. Some get broken. Some get shoved out of the good lanes. The belt belongs firmly to that second picture. It holds evidence that growth began, but nowhere does it carry the signature of one body that finished the job and cleared the zone. What is missing then is not a hidden object waiting to be found in the past. What is missing is a completed process. A finished planet gathers nearby material into one clear winner. The belt shows the opposite result. Many bodies survived, many fragments survived. Even some empty orbital lanes survived. The region still looks broad on a diagram, but its matter never ended up concentrated in one world. The old explosion idea stays attractive because it is easy to picture in one flash. There was a planet, then there was debris. The real answer moves more slowly. Growth began, the supply thinned. Jupiter kept shaping the region, collisions changed character, and a few bodies endured. That longer answer asks more of the imagination, but it matches the evidence far better. I should be careful here, because the low mass of today's belt does not on its own tell us how much material was out there at the very beginning. That deeper history has to be reconstructed from models, from the surviving bodies, and from the orbital evidence they leave behind. What the low mass does tell us, cleanly, is which kind of story is no longer believable as a first guess. A completed rocky planet is simply too big and too concentrated an object to vanish into the belt we actually see without leaving a far weirder trail than the one in front of us. Even the phrase asteroid belt can mislead. It makes the region sound permanent, as if this was simply the intended feature between Mars and Jupiter. It is better to hear the name as a label for a remnant. The belt is what stayed in orbit after a long history of partial growth, depletion, and later damage. It is an outcome, not a default. Once that lands, the first answer arrives without sounding like a shrug. The asteroid belt is too light to be the straightforward corpse of a lost rocky planet. The inventory is too small, the survivors are too varied, and the orbital structure carries too much meaning. That clears the easiest myth off the table and leaves the harder question standing in its place. If this region once took part in planet building, then what does planet building actually require before one body can take over a zone? Try feeling the scale in reverse for a moment. If you somehow scooped up every scrap of material in the belt and pressed it into a single object, you still would not get the kind of world the old myth keeps reaching for. The region has a grand address and an embarrassing bank balance. That contrast isn't a footnote. It's the first real clue, and it points away from catastrophe and toward something more interesting. So the belt teaches restraint before it teaches mechanics. It makes you give up the fast, dramatic picture and sit with a slower one, in which the simple fact of low surviving mass already rules out a mature, rocky planet as the end state. Only from there can the real investigation begin. You could almost call the belt a test of whether scale is allowed to lie. It lies to the eye by sprawling across a grand stretch of the solar system. It tells the truth to the scale, the actual weighing, by revealing how little is really there. So, from the very first step, the belt asks to be read not as the site of one late catastrophe, but as a place where you have to count both what gathered and what was lost. And it would be a mistake to treat that first correction as purely negative, as if low mass only told us what didn't happen. It points us somewhere too. The belt has the profile of a region that stayed plural. It never tipped over into the kind of concentrated system where one world inhales nearly everything nearby. That positive clue is worth as much as the death of the old myth, maybe more, because it tells us what kind of explanation is actually worth chasing. We tend to imagine planets as the natural destiny of rock. Put enough stone in orbit around a young star, wait long enough, and surely a world shows up. The belief feels obvious because the finished solar system looks like proof of it. 4 rocky planets on the inside, giant planets on the outside, a tidy schoolbook diagram. But that diagram hides how conditional the whole business really is. Matter on its own isn't enough. Time on its own isn't enough. A planet only forms when one encounter after another keeps rewarding growth instead of undoing it. Back in the early solar system, solid material did not start out as planets, or even as anything you could stand on. It started as tiny particles drifting in a disk around the young sun, mostly dust and grains. Those grains clumped into bigger clumps. The bigger clumps grew into bodies large enough to start mattering to each other through gravity. By the time the story reaches what astronomers call planetesimals, we have left behind the picture of dust floating passively in sunlight. Now we are dealing with objects that can collide, tug, deflect, and slowly rewrite each other's futures. This is the stage where a region gets to decide whether it becomes a nursery or a grinder. The cleanest way to feel that difference isn't through an equation, it's through motion. Picture two bodies moving along nearly the same path at nearly the same speed. When they meet gently, and a gentle meeting can let them stick, merge, or at least end up heavier than before. Now picture two bodies crossing each other with a big speed difference and a bad angle. That meeting is rough. A lot of energy has to go somewhere, and it goes into shattering, chipping, and scattering rather than building. The same lumps of rock can produce opposite outcomes purely because of the paths they happen to be on. This is why calm orbits matter so much, more than people expect. A good place to build a planet isn't just a place with material lying around. It's a place where that material keeps meeting under conditions that let you gain more than you lose. A small object picks up a little extra mass. The extra mass strengthens its gravity. Stronger gravity helps it grab still more. Growth compounds the way money does in an account you never touch. A region that actually produces a planet is one where enough of those tiny advantages keep stacking in the same direction for a very long time. There's a technical word for that stacking, and it only helps once you can already see the picture. Accretion just means growth by gathering up surrounding material. On paper it sounds dry. Up in the sky it means the neighborhood keeps letting success feed on itself. The body that gets a little bigger gets a better shot at getting bigger still, and the gap between it and everything else starts to widen. Once one object pulls clearly ahead, the difference between a future planet and a mere survivor begins to open up fast. The belt shows us what it looks like when that feedback stops being reliable. Bodies can still collide out there. Bodies can still survive. Some can even grow surprisingly large. But if too many of the encounters turn damaging, and if the region loses the calm it needs, then the compounding never gets a chance to dominate. Growth stays local and partial. Instead of one winner sweeping the zone clean, you're left with a banged-up population that just lingers. So the line, "There were rocks there, so why no planet?" isn't really a scientific question yet. It's only the opening intuition, the itch that starts the inquiry. What we actually need to ask is why the region stopped favoring net growth. Were the meetings too violent? Did the available mass drop away before any one embryo could pull ahead for good? Did a giant next door keep stirring the orbits and spoiling the conditions? A planet is not what you automatically get when matter exists. A planet is what you get when the environment keeps being kind to accumulation over and over for longer than feels reasonable. There's also a real difference between beginning and finishing, and the belt sits right on top of it. The belt contains bodies that prove the beginning happened. Ceres and Vesta are not pebbles. They are evidence that big steps up the ladder of growth actually got taken out there. So this isn't a story about a dead lane where nothing ever stirred. It's a story about a lane where growth got far enough to matter and still didn't manage the final sweep. That makes the failure more revealing, not less. If there were no large survivors at all, the answer might just be that the region never got the chance to start, and that would be a boring kind of failure. But the belt does have large survivors, so the real problem lives further down the chain, somewhere past the opening moves. Something about the local conditions kept cutting the line between meaningful growth and decisive dominance. The inner planets tempt us into treating their existence as the obvious payoff of any rocky disk. The belt is the correction to that temptation, standing right there in plain sight. It tells us the raw ingredients can be present, the process can genuinely begin, and the final object can still fail to show up. What matters next isn't the rocks themselves, it's the shape of the paths they were traveling, the architecture of the whole neighborhood. A growing body also needs luck in a sequence. Not luck just once. It has to keep meeting the right material under the right conditions again and again. One good collision won't do it. 10 might not do it. The environment has to keep rewarding growth across a long chain of encounters without too many bad links. That long, unbroken chain is exactly what the belt seems to have lost somewhere along the way. So the question is not really why the region lacked material in some basic sense. The question is why it lost the pattern of repeated success that turns material into a world. And once you frame it that way, the larger architecture of the solar system stops being background scenery and starts being the cause itself. The belt becomes a warning, then, against assuming matter will always find its way to a planet as long as nobody interferes. In reality, interference can be baked into the environment from very early on. If the neighborhood keeps making growth harder, right when growth is trying to compound, even real progress can stall out short of anything decisive. That's the deeper payoff of asking what a planet-building region actually needs to succeed. Another way to put it, planet formation is a long string of permissions. The environment has to keep saying yes. Yes to the next favorable meeting. Yes to the next useful capture. Yes to the next deepening of a lead. Somewhere between Mars and Jupiter, that permission seems to have been withdrawn before any single body could win. If the belt were nothing but a loose cloud of debris, its story would be much harder to hear, because randomness explains everything and therefore nothing. But the main belt is not random in that lazy way. When astronomers carefully mapped out the orbits of asteroids, they found something startling. There are missing lanes inside the belt. Certain distances from the Sun are oddly underpopulated. The region isn't a uniform spray of survivors. It looks as if some invisible editor walked through and kept deleting bodies from particular tracks. Those absences have a name, the Kirkwood gaps, and they are one of the cleanest clues in the entire problem. They are not holes in physical space, the way a child might first imagine them, like missing teeth in a ring. They are shortfalls in specific orbital ranges. A body that would circle the Sun with a period related to Jupiter's by a simple fraction, say 1 orbit for every 3 of the asteroids, can't comfortably stay there. Over time, the repeated gravitational nudges add up, the lane turns unstable, and objects drift out of it. The key word is repeated. People tend to describe Jupiter's role far too dramatically, as if the giant once swung through the belt like a wrecking ball and cleared it in a single pass. That picture misses what's actually elegant about the effect. Resonance is about timing, not force. A small push can matter enormously if it keeps arriving on the same beat. A child on a swing doesn't get launched by one giant shove. The swing climbs because modest pushes keep landing at exactly the right moment. The same logic runs the orbits out there. Jupiter doesn't have to grab an asteroid directly, it just has to keep meeting that asteroid's motion on a regular rhythm, and over a long enough stretch the lane comes apart. That's why the gaps matter well beyond their own edges. They prove the belt is not just a leftover heap of solids sitting in neutral space. It is a place where the timing of a giant planet has been carving structure into the distribution of small bodies for a very, very long time. The belt keeps Jupiter's fingerprint, and it keeps it in the negative space, in the lanes where almost nothing remains. The missing pieces are part of the evidence, maybe the most articulate part. This also upgrades what gravity means in the story. We usually talk about gravity as a simple pull, one body tugging another like a rope between them. But in a system of orbits that keep coming back around, gravity also behaves like rhythm. The same orbital relationships return on schedule. The same small nudges pile up. The effect is slow enough to be easy to dismiss, and persistent enough to rewrite the architecture of a whole region while nobody's watching. It's tempting at this point to slam the case shut. Jupiter disturbed the belt, therefore no planet. But that's still too quick, and I want to resist it honestly. The Kirkwood gaps show sculpting. They prove that some orbital neighborhoods were made unstable. They do not, by themselves, hand us the full mass history of the belt, or the entire collision record, or the exact route by which early growth failed. They are central evidence. They are not the whole verdict, and pretending otherwise would be its own kind of myth-making. Still, they change the emotional texture of the place completely. Before you know about the gaps, the belt is easy to imagine as passive leftovers, junk that happens to be lying between 2 planets. After the gaps, the belt becomes active architecture. These objects aren't sitting in a neutral room. They live next to a giant whose repeated timing keeps mattering, year after year, orbit after orbit. And once that's true, the fate of collisions changes too, because orbital structure governs not only where bodies can stay, but how hard and how often they run into each other. Picture a road network where some lanes are unreliable. Certain routes get jostled again and again, and a few intersections keep forcing sharper crossings. The pattern of traffic shifts even if the cars themselves never change. The same thing happens here. If some orbital neighborhoods are unstable, the paths of the survivors get bent. Objects are pushed off promising tracks. Others are kicked into more excited, more stretched out motion. The nursery gets harder and harder to keep calm. That word, calm, is what pulls us back to planet formation instead of leaving us stranded in orbital diagrams. A resonance isn't only an abstract mathematical relationship between two periods. In this story, it's a machine for changing the conditions under which bodies collide, persist, and grow. Jupiter writes the missing lanes, and the consequences of those missing lanes leak outward into the larger failure of accretion. The bookkeeping of where things can live becomes the bookkeeping of whether anything can grow. So the structure of the belt already tells us something decisive. The region did not fail because nothing happened there. It failed while sitting under the long, patient influence of a giant planet's timing. The empty-looking map between Mars and Jupiter is not empty of causes. It is crowded with them. We just have to keep following what those causes do to bodies in motion. There's a patience to resonance that makes it easy to underrate. Nothing about the gaps demands a single unforgettable moment. The effect is cumulative and quiet. It's the kind of influence that can spoil a promising lane long before any casual observer would think to blame the larger system at all. That quietness, honestly, is a big part of why the belt seems more mysterious than it really is. We keep looking for the loud event, and the real culprit was barely making a sound. For a nursery trying to finish even one planet, those missing lanes are not decorative trivia. They're warnings that some of the roads through the region never stayed safe enough for uninterrupted growth. A place with that much built-in instability can still cough up some impressive bodies, but it's a brutal place to let any single body inherit the whole ring. The Kirkwood gaps teach one more lesson, this one about absence itself. Missing bodies can be every bit as useful as present ones, as long as they're missing in a patterned way rather than at random. The belt is not just a collection of survivors, it is a collection of survivors surrounded by clues about which orbits stopped being hospitable. That pattern shoves the story toward dynamics, toward motion and timing, before we even let ourselves imagine a single growing embryo in isolation. And the gaps turn Jupiter from a distant backdrop into a participant in the scene. They show that you can't understand the architecture of the belt by staring only inward at the small bodies. The larger neighborhood keeps reaching in. That alone sets up the next move, because it lets us see how the belt could be active, populated, and still structurally cursed, all at the same time. A calm orbit is easy to overlook precisely because nothing about it grabs your attention. A body circles the sun on a nearly round path, stays close to the shared plane, everything else moves in, and meets its neighbors at gentle relative speeds. There's no spectacle in that, but spectacle is the wrong thing to look for here. Planet formation runs on long stretches of boring success, the cosmic equivalent of compound interest. The moment the orbits start to stretch out or tilt, the meetings stop being gentle, and that single change can wreck the whole nursery. Astronomers have names for these distortions, and the names sound colder than the ideas behind them. Eccentricity describes how stretched an orbit becomes, how far it departs from a clean circle. Inclination describes how steeply it tilts away from the common plane. Translate those into plain consequences, and they come alive. A stretched orbit changes where a body crosses the others, and how fast it's moving when it gets there. A tilted orbit changes the geometry of the crossing, the angle of the meeting. Pour enough stretch and tilt into a population of bodies, and the collisions get faster, harsher, and far less likely to end in anything growing. This is the bridge between Jupiter's dynamical reach and the failure to build a planet, and it's worth crossing slowly. The belt wasn't denied a planet by some decree or label. It was denied one because the cost of every encounter went up. Bodies that might once have met on cooperative, nearly parallel tracks started crossing with worse timing and more punishing energy. A collision that could have merged material under calmer conditions now chips it, excavates it, or flings it apart instead. Same bodies, same rock, different result, all because the motion soured. That doesn't mean every impact suddenly turns destructive overnight. Real systems are messier than a switch flipping from build to grind. Some collisions can still add material, some fragments fall back together locally and reaccrete. Some bodies take repeated hits and survive anyway, scarred but intact. What matters is the overall balance. A region builds a planet only when constructive encounters win out for long enough to let one body run away with the lead. The belt seems to have lost that balance, gradually, and then never recovered it. The physical meaning of stirring is easy to miss because the word itself sounds so mild. In a kitchen, stirring is what you do to soup. In orbital history, stirring is what you do to a fragile growth environment until the pieces stop meeting kindly and start meeting hard. The belt could stay packed with real objects and still become a worse and worse place to finish a planet, simply because the motion itself turned hostile to quiet accumulation. Nothing had to be removed for the situation to deteriorate, the bodies just had to start moving wrong. There's an important distinction lurking here between having building material and keeping a path to building open. The early belt may well have held far more mass than it does now, and that's a real part of the later story. But even a richer stockpile can fail if the local dynamics stop favoring net gain. More matter does not automatically rescue a region whose collisions are turning unforgiving. The quality of the encounters counts just as much as the sheer quantity of solids lying around. A rich, violent belt and a poor, violent belt both have the same problem at the moment of impact. This is also why we have to phrase the Jupiter answer carefully, even though it's tempting to keep it short. Jupiter prevented a planet is close enough to true to be seductive and loose enough to mislead. Jupiter mattered because it helped produce and then maintain the kind of orbital environment that works against orderly growth. The actual failure runs through the whole chain. Disturbed motion, then altered collision outcomes, then a thinning supply, then the slow erosion of any chance that one body could ever dominate. Naming only the giant skips 4 of the 5 steps, hold the region in your mind at 2 different moments. In the gentler moment, many bodies travel on similar tracks, and their encounters are frequent enough and soft enough that a few of them start pulling ahead. In the harsher moment, the tracks cross at bad angles, the speeds climb, some lanes are openly unstable, and bodies that were growing now spend more of their lives absorbing damage and shedding fragments than gaining ground. The evidence the belt has actually preserved points much more strongly toward that second, harsher moment. Once a region reaches that state, time stops being your ally. People love to say, given enough time, as though time is automatically constructive, as though waiting always builds. But in a dynamically excited belt, more time just means more opportunities for subtraction, more chances for material to get chipped away, more chances for debris to be flung around and redistributed, more chances for a promising embryo to remain, stubbornly, only an embryo. The clock keeps running, but it's running for the demolition crew now. So the story can't end with simple growth physics, satisfying as that would be. The belt didn't stay gentle enough for long enough. A few bodies still managed to become genuinely impressive, and that matters enormously because it proves the place wasn't hopeless. Ceres and Vesta show the nursery was never trivial, but those successes sit inside a larger environment where the motion was steadily becoming less forgiving than a planet can tolerate. From the point of view of a growing embryo, this is the cruelest part of the whole story. A body can rack up real gains and still fail, simply because its next 1,000 encounters arrive under worse terms than the previous 1,000. Planet formation demands not just progress but the preservation of a favorable future, a guarantee that tomorrow will still reward what you built today. The belt seems to have kept revoking that guarantee. That's why disturbed motion deserves to be heard as a hard physical fact, not as some decorative footnote about orbits. Stretch and tilt in the tracks decide whether the next meeting adds mass or takes it away. In the belt, that difference may well have been the difference between a world that was still genuinely possible and a world that never got one more clean shot at existing. Here's a picture I keep coming back to. Imagine a builder laying stone while the ground under the work keeps getting less predictable, shifting a little more with each course. The builder might still raise a strong stretch of wall, but the odds of ever finishing the whole structure keep slipping away. The belt seems to have lived inside exactly that kind of instability. Some bodies gained real stature, while the larger environment grew less and less willing to let stature turn into sovereignty. And a region that keeps stirring itself out of favor doesn't have to destroy every serious body to fail. It only has to make long-term success harder than long-term interruption. That's a crucial distinction, because it explains how the belt can hold substantial survivors and still show a final absence at its center. The belt preserves precisely that combination, the big bodies and the missing planet, and the combination is the whole point. Ceres changes the mood of the belt the instant it comes into view. If the region held nothing but small, jagged fragments, the failure of planet building would feel almost expected, even unremarkable. A field of rubble doesn't by itself suggest a promise that got interrupted. But Ceres is a different kind of object entirely. It is round. It is recognized as the only dwarf planet in the inner solar system. And when NASA's Dawn spacecraft slipped into orbit around it in 2015, the belt finally got a clear face for its largest surviving clue, a world we could photograph instead of merely plot. Roundness isn't just a visual nicety. It means gravity got strong enough to pull the body into a ball, overcoming the strength of its own rock. Ceres is about 940 kilometers across, and it holds something like a quarter to a third of the entire belt's mass in that one object. It reached a scale where it stopped looking like a random shard and started looking like something that had crossed a threshold. It is not a full-blown terrestrial planet hiding in miniature, and nobody should sell it that way. What it does show is that growth in the belt got real enough to make a large, self-rounded world with a geological story all its own, complete with hints of briny water and a crust that has clearly been reworked over time. That is why Ceres keeps the central mystery alive rather than putting it to rest. If the region could grow one body this far, then the question is no longer whether growth ever started. The question becomes why growth stopped short of dominance. Why didn't one embryo, maybe Ceres itself, maybe a rival now long gone, keep gathering the surrounding material until the whole neighborhood reorganized around it? Why did the climb stall right there, partway up? It helps to think of Ceres not as a failed Earth, but as a surviving midpoint, frozen in place. On a healthy planet-building ladder, bodies cross intermediate rungs on their way to something larger, and most of those rungs vanish because the bodies either grow past them or get absorbed. Ceres looks like one of those rungs that simply stayed. It tells us the workshop was open and busy. It tells us the materials were taking part. It tells us the region pulled off enough local success to make at least one object whose very shape announces that size came to matter out there. But Ceres also announces a limit, and it announces both things at once, which is what makes it so eloquent. A rounded dwarf planet sitting in the belt is strong evidence that the region was never empty from the start. It's equally strong evidence that the region never kept feeding one winner all the way to completion. Ceres survived as a large body inside a system that never fully reorganized itself around any single body. That's the strange pairing at the core of the whole topic. Significant growth happened, decisive takeover did not. The two facts live in the same object. A lot of the emotional pull of Ceres comes from how solitary it feels out there. It sits inside a zone now known for fragmentation, for collision families, for gaps swept clean by Jupiter. Its presence makes the belt feel less like a junkyard and more like a place where building materials and half-finished outcomes were left scattered in different states of completion, like a construction site abandoned mid-project. A rounded little world among so many smaller remnants carries an almost architectural sadness. Something real began there, and then it stopped. None of that means Ceres was destined to become the missing planet of the region. That kind of confident counterfactual would reach well past the evidence, and I'd rather not. The safer and better claim is simpler and stronger. Ceres proves substantial growth happened inside the broader history of the belt. It preserves the fact of possibility without pretending to preserve one predetermined future that was stolen away. Possibility is enough. It doesn't need to be inflated into destiny. There's a useful boundary to keep in view as well. Ceres itself belongs squarely to the observed side of the story. Its shape, its position, its size, its status as the only dwarf planet in the inner solar system, these are direct facts we can point to. What those facts imply about incomplete planet building belongs to interpretation, and the line between the two should stay visible. Keeping that boundary honest is what lets the evidence stay strong without ever claiming to say more than it really does. Another reason Ceres matters is that it stops the whole story from collapsing into a Jupiter lecture. Giant planet dynamics are indispensable here, and I've spent real time on them, but the belt is not only an arrangement of orbits, it is also a population of bodies with different growth histories written into them. Ceres reminds us the zone was physically productive before it became permanently incomplete. The story belongs to motion and to matter, both, and you lose half of it if you only talk about Jupiter. Seen this way, Ceres is almost a question made visible, hanging there in orbit. Here is a body large enough to prove the nursery could work. Here is that same body sitting in a region that never produced a final planet. The gap between those two truths is exactly where the rest of the answer has to live, and Ceres holds that gap open for us, so we can't look away from it. And once Ceres has done that work, Vesta becomes even more revealing. Ceres shows scale, the sheer fact of size. Vesta shows internal evolution, the fact of a body that cooked and sorted itself from the inside. Together they make the belt almost impossible to dismiss as a simple pile of leftovers. Two witnesses, telling complementary halves of the same story. There's an emotional lesson in Ceres too, and I don't think it's sentimental to say so. The body keeps the belt from sounding like a place of pure negation, of nothing but failure and loss. Something affirmative happened out there. Matter did gather, gravity did organize it. A genuine little world did emerge, and is still emerging, still geologically restless. That affirmation is what makes the later incompletion sting, and it's also what makes it explanatory. You can't be disappointed by a place that never tried. Ceres proves the belt tried, so picture Ceres as a survivor of an interrupted promise. It stands far enough up the ladder to prove the ladder was real and being climbed, and far enough below a finished planet to prove the ladder was never climbed to the top. That's exactly the kind of witness this question needs, one that testifies to both the effort and the shortfall in a single breath. Vesta does not look like a pebble that wandered into the wrong documentary. It looks battered, scarred, and substantial, like something that has been through a lot and has the marks to prove it. Dawn, the same spacecraft that later visited Ceres, found a body whose rough terrain sits in a strange middle ground, more evolved than the word asteroid prepares you for, and less complete than a finished planet. At roughly 525 kilometers across, it is the second largest object in the asteroid belt after Ceres, and it carries the marks of both early development and later violence on the same surface. The most important thing about Vesta is hidden from a casual glance, because it's on the inside. Its interior history matters more than its battered face. Evidence from Dawn, combined with the link to a family of meteorites called the Head A's, points toward a differentiated body, one that once got hot enough and organized enough for heavier material to sink toward the center. NASA's description includes support for an iron core. That is not a small thing. It means Vesta was never just a loose clump of primitive rubble. It was a small world with an inside that changed, that separated, that behaved. Differentiation is one of those words that sounds heavier than the picture behind it, so let me put it plainly. It means the body sorted itself out. Heat and gravity let the material settle by density, with the dense stuff sinking and the light stuff rising, the way oil and water separate if you leave them alone. The object developed an internal structure instead of staying a uniform lump all the way through. That step belongs to the very same broad family of processes that run during planet building. Vesta never finished becoming a planet, but it clearly passed through planet-like development on its way to stalling. This is what makes Vesta such a good witness, maybe the best one. Ceres proves that large surviving growth exists in the belt. Vesta proves that deep internal evolution happened there too. Put them together and they close off the lazy idea that the belt is just a museum of unimportant stones. Some of its major inhabitants took part in the early solar system at a far more serious level than their current address would ever suggest. They didn't just sit there, they evolved. And then there are the scars. Vesta's enormous impact basins, especially Re Silvia near its south pole, a crater so big it reshaped the whole bottom of the world, show another part of the belt's history. Growth and damage are written on the same object side by side. The body is evolved enough to matter, and wounded enough to show how dangerous the environment could become. A place capable of producing internally organized little worlds was also a place capable of carving titanic blows into them, sometimes nearly splitting them apart. That combination is almost the entire belt compressed into one object. The nursery was real. The interruptions were real. Vesta holds both truths at the same time, in the same rock. It tells us the failure of planet building was not a failure at the first step, not a region that never got going. It was a failure that came after meaningful progress had already been made, which is a much more interesting kind of failure. There's a discipline to keep here, the same one I held for Ceres. Vesta should not be turned into the missing planet by a back door. It is not a hidden almost Earth, and its scars are not evidence that some full terrestrial world exploded next to it. The point is not to inflate Vesta into a lost giant. The point is to recognize that the belt contained bodies with enough heat, scale, and structure to count as genuine participants in early world-making. That's a strong enough claim. It doesn't need exaggeration to carry weight. Meteorites drive that point home in a way nothing else can. The link between Vesta and the Hadees meteorites found on Earth means a piece of that body's history physically reaches us. We are not only reading distant light through telescopes and inferring. Actual fragments of Vesta's story have landed here, been picked up and been sliced open in laboratories. That gives the belt a tactile intimacy that surprises people. The failed planet-building region between Mars and Jupiter is not wholly remote and abstract. Bits of it have crossed the gap and fallen into our own world, and we can hold them. Vesta also sets up the collision history still to come. A differentiated body with giant basins is exactly the kind of object that shows how subtraction can take over after growth has already begun. Material gets excavated, debris gets launched into space, families of related fragments appear, all sharing a common origin in one big hit. The region doesn't simply preserve what it once built. It keeps revising it, chipping at it, breaking pieces off and scattering them. So Vesta extends the meaning of the belt in a different direction from Ceres, and the two directions matter. Ceres says the region made something large enough to pull itself round. Vesta says the region made something deep enough to sort itself internally and tough enough to survive enormous damage. Neither object is a finished planet. Both make incomplete planet building impossible to wave away. You can dismiss a pile of gravel. You cannot so easily dismiss a differentiated little world with an iron core and a crater the size of a continent. After Ceres and Vesta, the present belt stops looking like a mere absence between better-known worlds. It looks like a thinned-out field of survivors that once belonged to a more ambitious process. And that naturally raises the next question, the one that has been waiting in the wings. If the belt is so small now, did it always contain this little material, or did a great deal of its original inventory simply go missing? Vesta's physical link to the meteorites in our collections adds one more layer of reality to all of this. Pieces of this interrupted region didn't just stay in orbit, circling forever. Some of them crossed the gap to Earth and are sitting in display cases and lab drawers right now. The belt's history isn't only a distant abstraction about missing lanes and inferred depletion. It has, quite literally, arrived here in stone, and we have studied it under microscopes. That tactile connection matters because it grounds how concrete the evidence really is. The region between Mars and Jupiter is not merely a mathematical story about gaps and modelled losses. It is a place that produced differentiated bodies, suffered giant impacts, and sent fragments outward across the solar system, some of them all the way to us. A place with that much history was never a trivial belt of leftovers, and Vesta is the proof you can practically put in your hand. One of the most important acts of honesty in this whole story is learning to separate what we measure directly from what we reconstruct. The present belt is directly measurable, at least in broad strokes. Its low total mass is a fact. Its major bodies are facts. Its current orbital structure is a fact. But the early inventory of the belt, how much material was actually out there at the start, is not something anyone watched with a camera. That part has to be inferred, drawn out of models of the surviving bodies and of what planet formation itself demands in order to work. Even with that caution firmly in place, the safest broad conclusion still hits hard. Today's belt looks depleted. It does not look like a region that quietly hung on to everything it started with and just forgot to finish the job. The present mass is so small that many researchers treat the belt as a remnant rather than an untouched reservoir, the dregs rather than the full cup. Something in its history involved serious loss of usable building material, and a lot of it. That matters because supply is not a side issue, it's load-bearing. A growing planetary embryo needs more than calm collisions. It also needs enough raw feedstock in its neighborhood for growth to keep going once it starts. If the inventory drops too far, a region can fail even before the last rounds of competition get decided, simply because there isn't enough left to build with. A planet does not emerge from an empty pantry, no matter how patient the clock is or how perfect the conditions otherwise are. The depletion idea lands so strongly because the present belt fails two simple tests at once. It is too light to be the remains of a normal rocky planet, and it is also too light for a long-lived, well-stocked nursery that somehow just ran out of luck at the last moment. A region that stayed rich and quiet for long enough should have given one embryo a much better chance to take over. The survivors we have, paired with the small remaining mass, suggest that chance was cut down much earlier. It is also worth keeping the picture calm. Depletion does not require one giant purge. A region can become poorer slowly. Material can be scattered away, driven inward, or broken into paths that no longer help one body pull ahead. The important point is not one dramatic act of removal. The important point is that the belt seems to have lost too much useful building material to stay a strong nursery. So the careful way to say it is also the most durable way to say it. The present belt is light, and many models imply a more massive, earlier state. The exact starting inventory remains model-dependent. What we can say safely is that the modern belt appears to be a depleted remnant of a more complex early reservoir. That phrase, depleted remnant, carries a lot of explanatory weight for two plain words. It means the belt we see now is not the whole story, only the surviving slice of it, the part that made it through. It means absence has to be counted right alongside presence in the ledger. The empty-looking space between Mars and Jupiter is not just where no planet stands. It's also where much of the original opportunity seems to have been carried away before any planet could form. Once that idea settles in, the old myth weakens for a fresh reason. The belt isn't short on drama because nothing ever happened there. It's short on drama because the relevant history is architectural rather than explosive. A great deal of the action probably consists of material quietly failing to stay where a simple diagram expects it to stay. That kind of change is far quieter than a blast and, in the long run, far more consequential for the future of a nursery. Slow leaks sink more ships than cannon fire. There's also a deeper comfort in admitting the boundary between observation and reconstruction, and I'd rather lean into it than hide it. It keeps the answer from puffing up beyond what it's earned. The present facts are strong enough to steer the story. The inferred past is strong enough to shape the answer without ever pretending to be eyewitness testimony. That balance is exactly what a question this old and this incomplete deserves, and it's more honest than false certainty would be. So the belt's missing inventory becomes part of the headline answer, not a subplot. A planet failed to emerge out there not only because the local dynamics turned hostile, but also because the region seems to have lost too much of the very material a dominant body would have needed to grow on. Which sets up the next move directly. How might a nearby giant have helped create that poorer, rougher nursery in the first place? Because supply problems and motion problems don't sit in separate boxes. They feed each other. A thinner reservoir means fewer chances to recover from a bad collision, fewer nearby bodies worth capturing, and fewer openings for a leading embryo to turn a modest lead into a decisive one. Once the inventory falls, the belt stops feeling like a planet in waiting and starts feeling like a system already spending down its savings, drawing on a balance that only ever shrinks. That's why depletion shouldn't be heard as an afterthought tacked onto the dynamics. It's one of the conditions that makes the later failure understandable in the first place. A region that loses too much material too early can stay full of fascinating survivors and still become flatly incapable of delivering the one outcome the map keeps inviting us to expect. Walsh and colleagues help make that missing inventory easier to picture because their migration model does not remove mass in one theatrical sweep. Jupiter moves inward and then back out, while Saturn joins the turn. In the process, the inner disk is truncated, Mars is left starved compared with Earth and Venus, and the asteroid belt is first emptied and then repopulated with a thinner mixed population. Even if that exact route turns out to need revision, the useful lesson is immediate. The belt does not have to begin poor in order to end poor. A region can be robbed while the rest of the solar system is still under construction. That helps explain why the modern belt feels so unlike a nursery that simply ran out of patience. A nursery that kept most of its stock would leave room for a late winner, especially over billions of years. The belt leaves room for something else instead, a few survivors that grew part way, a population that stayed plural, and a mass ledger that looks as if the cupboard was emptied before the strongest body could dominate. Ceres and Vesta make more sense in that poorer setting. They stop looking like the first pieces of an inevitable planet and start looking like bodies that survived after the broader reservoir was cut down around them. Put the same point another way, if the belt once held much more solid material, then depletion is not a decorative extra added after the fact. It is one of the moments when the future of the whole region tilted. Losing feedstock early does more than shrink a number in the ledger. It reduces the number of mergers still available, lowers the prize for any embryo trying to pull ahead, and makes every later collision harder to recover from. By the time Jupiter's timing marks and the late collisional scars become visible, the belt may already be living on borrowed mass. It's easy to picture the early solar system as just a smaller, younger version of the one we have now. The Sun in the middle, the planets already parked near their familiar spots, the asteroid belt already waiting between Mars and Jupiter like a permanent border drawn on the map. But some of the most influential models throw that assumption out. They don't treat the giant planets as fixed scenery at all. They treat them as actors, bodies whose early movement helped rearrange the architecture around them, sometimes drastically. There's a related piece of the puzzle worth pausing on first, because it explains why Jupiter got so big in the first place. Out beyond a certain distance from the young Sun, sometimes called the frost line or snow line, it was cold enough for water and other volatiles to freeze into solid ice that suddenly gave the outer disk a lot more solid material to build with. Not just rock and metal, but ice too. A growing body out there could bulk up fast enough to start grabbing gas before the disk dispersed. That head start is a big part of why Jupiter became a giant while the inner bodies stayed small. And a giant, once it exists, is exactly the kind of neighbor that can dominate everything near it, including the belt just inside its orbit. One important family of models gets gathered under the name Grand Tack. In that picture, Jupiter doesn't simply form where we see it now and stay put. During the gas-rich early epoch, Jupiter may have drifted inward toward the Sun and then turned and drifted back out again, with Saturn caught up in the same dance. Walsh and colleagues argued that this kind of motion can account for several big features all at once, including the puzzlingly low mass of Mars and the depletion and compositional mixing of the asteroid belt. One mechanism, several stubborn facts explained together. The appeal of that model isn't that it gives us one elegant flourish to admire. The appeal is that it turns depletion from a bare assertion into a physical story you can follow. Moving giant planets shift their resonances around as they go, sweeping those zones of instability across the disk like a broom dragged through dust. They change which regions stay hospitable to small bodies and which don't. They can carve, empty, scatter, and even later repopulate zones that we'd otherwise be tempted to imagine as static and untouched. In that picture, the belt isn't a shelf nobody bothered. It's a corridor that got reorganized more than once by heavyweight neighbors passing through. Here's another place where a plain image helps more than technical prestige. Drag a heavy object across a crowded room, and the room is not arranged the same way afterward. Paths get blocked, small things get shoved aside, and a few objects end up wedged into corners they never would have reached on their own. The early solar system wasn't a room, obviously, and the analogy has its limits, so don't lean on it too hard, but it captures the core lesson. If Jupiter and Saturn changed position while the disk was still young and crowded, the consequences for the small bodies between Mars and Jupiter could have been enormous. At the same time, I want to keep the uncertainty around any migration model audible because it's real. This is not a witnessed replay of history. It's a reconstruction built to satisfy several surviving facts at once, and reconstructions can be revised. That's exactly why it's useful, and also why it shouldn't be mistaken for footage of the young solar system. Grand Tack earns its keep because it explains several features together, not because anyone watched it happen. Hold it firmly and lightly at the same time. Even with that restraint, the model contributes something genuinely valuable to the larger answer. It shows that the belt's failure might reflect more than local bad luck, more than one region drawing a short straw. The architecture of the entire early solar system could have leaned against success out there. A migrating Jupiter wouldn't merely stir the existing bodies in place. It would help decide which bodies remained at all, which ones got removed, and how thoroughly the surviving population got mixed and diminished along the way. That mixing matters because the belt does not look compositionally simple. In the broad model picture, bodies from different birth zones can end up sharing the same modern address after the migration era has done its work. A region that has been emptied and partly restocked is already hard to imagine as the clean cradle of one future planet. Its members do not all arrive carrying the same straightforward origin story. They arrive as survivors of a rearranged system. That point also keeps Jupiter from shrinking into a one-line villain, which I think is important. Jupiter stopped a planet is a sentence far too small for the evidence. Jupiter's importance lies in the sheer number of ways a giant neighbor can change the rules of the game. Resonances can empty specific lanes, stirring can drive up collision speeds, migration can reshape entire reservoirs. Supply can be cut off before a dominant embryo finishes growing. The answer is layered because Jupiter's influence is layered, reaching the belt through several different mechanisms at once. There's also a quiet elegance in how these ideas connect the belt to other features of the inner solar system, and it's easy to miss. Mars, being so comparatively low in mass, is not a random side fact floating off on its own. In several reconstructions, it belongs to the same broader architectural story that leaves the belt depleted and dynamically beaten up. So the question of why no planet formed in the belt may not be an isolated puzzle at all. It may be one expression of how the giant planet's early history reshaped the whole inner neighborhood, Mars included. What matters most for the belt itself is the shift in perspective this forces on us. Instead of imagining a passive ring of fragments that somehow never got around to finishing the job, we start seeing a nursery whose environment may have been interrupted and reorganized repeatedly by planetary motion on a grand scale. That's a much harder scene to picture than a single explosion, no question, but it's also far closer to the evidence-led spirit the topic actually demands. Migration models open up another possibility too, one that's easy to overlook. If the belt was not only depleted but partly repopulated from more than one source region, with bodies delivered in from elsewhere, then the modern population records a history of rearrangement as much as loss. The zone wouldn't simply be poorer than it started. It would be rewritten, stocked with material from different birthplaces, which makes the path toward a single clean dominant planet even less straightforward than depletion alone would suggest. And once the nursery has been depleted and stirred, collisions stop meaning what they would mean in a calmer, richer place. They no longer promise slow repair, the patient gathering back of scattered pieces. More often, out in a belt like this one, they become just another form of subtraction, which is exactly where the story has to go next. There is an easy hope that clings to any field of fragments. If enough pieces are still circling, perhaps enough time will let them settle down and gather again. Perhaps the asteroid belt only looks unfinished because we are meeting it late. That hope fades once the physical setting comes back into focus. The later belt is poor in mass, rough in orbital conditions, and shaped by a history in which bad impacts mattered more than gentle mergers. By the time the modern belt emerges, time is no longer an ally of assembly. Time is part of what keeps revising the leftovers downward. The first correction is visual. The belt is not a crowded stone river with rocks constantly smashing in every direction. Spacecraft can cross it because most of it is empty space. That emptiness does not rescue the planet-building idea. It changes the timescale in which danger works. In the belt, rare encounters can still dominate the history because the clock is so long. Give a body hundreds of millions or billions of years, and even infrequent destructive collisions become decisive. Vesta is the clearest object for this part of the story because Dawn showed the wound in plain shape. Resilvia near the South Pole is so large that it dominates the body. You can look at Vesta and see that a great deal of material was excavated from an object that had already differentiated. That matters more than the drama of the blow itself. The event did not gather mass back toward one winner. It cut mass out of a little world that had already done serious growing. The HED meteorites linked to Vesta make that subtraction tangible. Some of the rock blasted from Vesta did not stay politely near home, waiting to help rebuild anything. It entered asteroid families, changed orbits, and in a few cases eventually reached Earth. When a stone in a laboratory can be traced back to a scarred, differentiated body in the belt, the history stops sounding theoretical. We are looking at evidence that the late belt exported pieces of earlier success instead of feeding them into one final planet. That example carries special weight because Vesta was never a trivial stone. Heat had already sorted heavy material downward. An iron core was already part of the story. In other words, the body had crossed far beyond the stage of loose primitive rubble. If a place can produce a world with an inside and later carve a basin like Resilvia into it, then the late belt is not a patient workshop waiting to resume. It is a region that keeps revising what earlier growth managed to build. This is the plain meaning of collisional evolution. The phrase can sound abstract, as if it belongs on a chart rather than in a physical place. The place is simple enough. Bodies strike, surfaces change, fragments appear. The surviving population is edited over time. Editing is the key word. A population can remain scientifically rich while becoming worse and worse at producing one dominant world. That difference between survival and progress is easy to miss. A listener can hear that asteroids still exist and assume the old ingredients were preserved for later use. But preserved is the wrong word for most of the late history. The material is still there in some sense, yet it is present in a processed form. Pieces have been chipped away, orbits have been altered, fragments have already lived through previous collisions. The belt is not storing fresh building blocks on a shelf. It is circulating matter that has already paid a long price. Imagine trying to build a wall from stones that keep being cracked, scattered, and removed from the pile before the structure rises above knee height. The problem is not that no stones remain. The problem is that the condition of the pile keeps worsening. That is much closer to the belt's later history. Earlier growth left real bodies behind, but the long later environment kept acting on them in ways that favored redistribution over completion. The smaller bodies face an even harsher version of the same reality. Vesta can survive a titanic blow and still remain Vesta. A smaller asteroid may be broken beyond recognition by a much less famous encounter. It can be shattered into pieces too small to matter for future dominance. It can be nudged into a resonance that changes its entire future. It can lose the limited material that might have fed local growth. The later belt is therefore selective in a cruel way. Large survivors keep scars. Smaller ones often become part of the scar field. That does not mean the belt lives in non-stop violence. Most of the time, nothing visible happens at all. The important point is that long, quiet intervals do not undo the damage once conditions have turned against growth. A body can spend ages circling harmlessly and still end up defined by a single bad encounter. When that pattern is repeated across a depleted population for immense spans of time, the region keeps moving away from completion even while it looks calm from a distance. That is why the question, could the belt have finished the job later, has such a stubborn answer. Later was the problem. By later times, the inventory had already been thinned, the orbits were still not calm enough, and the cumulative damage of bad impacts had become part of the environment. Building a planet requires favorable outcomes over and over again. Breaking a body may require only one encounter that arrives under the wrong terms. Once the balance tipped, the region did not need continuous violence to stay unfinished. It only needed enough harmful encounters spread across immense time to keep the wrong direction alive. There is a false comfort in words like leftovers and debris because they sound usable. Leftovers in a kitchen can be reheated. Debris after a storm can be gathered into a pile. Leftover mass in the asteroid belt does not behave that way. It remains inside a hard orbital setting, already reduced, already stirred, and still vulnerable to subtraction. The pieces are real. Their future is not a second clean attempt at the same task, so collisions are not an afterthought added once Jupiter and depletion have done the main work. They are part of the main work. They explain why an already damaged nursery kept moving farther from completion instead of drifting back toward it. In the asteroid belt, the later ages did not mend the interruption. They made the interruption durable. Seen that way, the modern belt is not a paused construction site. It is the long, late state of a construction site whose best conditions expired. The project did not sit untouched. Weather got in, tools were lost, materials were carried away. The remaining pieces still tell the story, but they tell it as evidence of a job that became harder with time, not easier. The exploded planet story survives because the map makes it feel effortless. Mars circles on one side, Jupiter waits on the other. Between them sits a broad zone of fragments. The eye wants to drop a missing world into that address, and then explain the fragments as wreckage. The fit is so immediate that many people never feel the need to ask whether the physical clues actually behave that way. Mass is the first clue that refuses to cooperate. NASA's plain number is still the best antidote because it is so unadorned. All the asteroids together contain less mass than Earth's moon. Once you really hear that, the imagined blast has a bookkeeping problem it never asked for. A finished rocky planet is a large concentration of matter. The modern belt is not. To rescue the myth, almost all of the missing mass has to disappear into a second story that is usually left unstated. Kirkwood gaps push back in a different language. They are not the kind of structure you expect from one world breaking apart and leaving random leftovers. They are timing marks. Certain orbital lanes are underfilled because Jupiter keeps finding the same beat in those orbits and perturbing them over and over again. That repeated rhythm sounds like long-term sculpting, not a single tragic afternoon. The gaps keep reminding us that the belt was lived in by dynamics, not merely littered by one catastrophe. Ceres makes the myth harder still. It remains where it is, round and substantial, the only dwarf planet in the inner solar system. A round survivor embedded in the belt does not read like a neat shard from one vanished terrestrial world. It reads like a body that grew partway in place. Vesta adds a second refusal. Dawn found a differentiated object with giant impact basins, and meteorites linked to Vesta now sit in collections on Earth. Those are not generic fragments. They are pieces of individual biographies. There is a physical texture problem too. When people imagine an exploded planet, they often imagine a crowded wreck field, a bright, violent ring of fresh debris. The actual belt does not behave that way. It is sparse enough for spacecraft to cross. Its bodies occupy structured lanes rather than one glowing spray. Its largest survivors keep their own histories instead of dissolving into one anonymous cloud. Even before we explain every detail, the scene in front of us does not resemble the instinctive movie version of a lost world. The myth also struggles with the simple fact that Ceres does not look like a shard. It sits in the belt as a round dwarf planet, a body that reads more naturally as local growth than as leftover splinter. Vesta adds a different problem. It carries the record of differentiation and a giant south polar excavation. Together they point toward a population that matured unevenly, not toward one uniform world that later burst apart into matching pieces. Once those biographies enter the picture, the emotional center of the topic moves. The belt no longer wants to be heard as a crime scene after one explosion. It wants to be heard as a workshop where construction began. Some pieces became impressive, supplies ran thin, and later damage kept arriving before one object could dominate. That workshop image is less cinematic than a blast, but it matches far more of what the belt actually preserves. There is no need to sneer at the older story. The temptation is real. People are reacting to a visible pattern. The correction only begins when you ask a stricter question. Do the low mass, the resonant lanes, the round dwarf planet, the differentiated survivor, and the collisional scars behave like the remains of one finished world? They do not. They behave like the remains of interrupted world-making. That quieter answer ends up being larger, not smaller, because it teaches more. A destroyed planet would explain only loss. A failed nursery explains why a location that looked promising could still remain plural, underfilled and unfinished for billions of years. It turns the belt from a single melodrama into a lesson about how demanding planet formation really is. You can feel the difference by imagining a workshop after the workers have gone. Materials remain, but the finished object was never completed. Some parts are substantial. Some supplies are missing. A few damaged pieces show that rough events happened after real progress had already been made. The asteroid belt keeps behaving like that kind of place. Memory prefers the first room because it can be understood in one glance. The second room asks you to reconstruct a history. That is why the myth remains sticky. It compresses better. Compression, though, is not the same as truth. The belt rewards the slower picture. When low mass, Jupiter's timing, depleted supply, Ceres, Vesta, and later collisions are allowed to stay in the same frame, they keep telling the same quieter story. So the better explanation does not take wonder away from the belt. It gives the belt a harder and more interesting kind of wonder. The region is not where a finished world died. It is where the conditions for finishing a world kept slipping away. One of the habits the solar system teaches by accident is the habit of inevitability. We grow up surrounded by finished worlds, so finished worlds start to feel like the natural destination of rocky matter. The asteroid belt breaks that habit. It says planets are outcomes, not promises. That does not make planet formation miraculous. It makes it conditional. A region needs enough material, enough time, gentle enough encounters, and a wider architecture that does not keep undoing the work. Remove one of those supports and growth can slow. Remove several and growth can begin in earnest without ever producing a final dominant body. The belt makes those conditions feel real because it preserves the marks of what went missing. Imagine a body in the young belt trying to climb. It needs nearby solids to keep falling within reach. It needs many meetings to be calm enough that added mass outweighs damage. It needs the neighborhood to stay stable for long enough that an early lead can compound. Between Mars and Jupiter, that climb keeps running into a different kind of scene. The reservoir thins. Jupiter keeps its timing pressure on the lane. Later collisions arrive in a zone that has already lost too much of its margin. Time belongs inside that picture too, but not as an endless open field. The young solar system had deadlines built into it. Gas surrounded the disk for only a limited interval. Jupiter's own rise belongs to that early schedule. A small body reservoir that needed a long quiet stretch could lose its chance while the architecture of the whole system was still changing quickly. The belt did not get billions of years of favorable conditions and then somehow waste them. It likely lost the favorable interval early and spent the later billions of years living with the consequences. That is one reason Mars belongs nearby in the conversation. Mars is not inside the belt, yet its oddly low mass compared with Earth and Venus hints that the inner solar system was not stocked and shaped evenly. In model classes such as Grand Tack, the same rearrangement that starves Mars also helps deplete and remix the asteroid reservoir. The details remain arguable. The connection itself is valuable because it shows the belt may be one expression of a larger architectural story rather than a local accident in an otherwise smooth system. That wider setting helps guard against one more misunderstanding. The belt did not fail in a vacuum, while the rest of the solar system followed a separate script. Its history sits inside the same formative era that produced Jupiter, limited Mars, and sorted the inner and outer reservoirs differently. The condition problem is therefore not a narrow local glitch. It is part of how the whole system was being organized while the clock was still running fast. That is one reason the belt feels so revealing. It lets us see a local failure without pretending the rest of the system stood still around it. The same early architecture that made Jupiter important and left Mars underfed also changed the stakes for the material between them. That shared setting keeps the belt tied to the solar system's bigger story today, instead of letting it shrink into a side case. Nothing there unfolded in isolation from the rest of the architecture. Meteorites help because they turn that early schedule into evidence instead of mood. Pieces linked to Vesta preserve heating, melting, and differentiation. They tell us that some belt-related bodies advanced far enough for interiors to separate while the system was still young. That is not an imagined first act, it is a physical record. The later basins on Vesta then add a second message. Surviving into the mature belt meant surviving later damage in a region that had already become hard on its own products. Think about what that means for any growing embryo caught there. Getting ahead once is not enough. The lead has to survive supply loss, survive rougher orbital traffic, and survive the next bad collision without surrendering too much mass. A richer and calmer neighborhood can forgive more setbacks. The belt seems to have lost that forgiveness early. That changes how we should think about location itself. Orbital space is not neutral real estate, where solids calmly do the same thing everywhere. Put one nursery well away from a giant neighbor and another just inside Jupiter's reach, and you have not merely changed the address on the map, you have changed the pattern of repeated perturbations, the encounter speeds likely to build up, and the odds that a local winner can keep widening its lead. The neighborhood participates in the outcome. An ordinary comparison helps. A seed can be healthy and still fail if the soil is thin, the light is poor, or a larger root system keeps disturbing the ground around it. We do not say the seed never existed. We say the conditions were wrong for maturity. The asteroid belt looks like that kind of case. Growth was genuine. Maturity was not secured. That matters beyond the belt because it stops us from treating the inner planets as automatic outcomes of any rocky disk. Mercury, Venus, Earth, and Mars are the visible successes. The belt is the visible counterexample that stayed nearby enough for us to inspect in detail. It shows what happens when similar raw ingredients occupy a harder address and lose the chance to turn early growth into final authority. Jupiter belongs inside that lesson, but not as a melodramatic villain. It is part of the architecture. Its repeated timing shapes orbital lanes. Its gravity helps keep the region dynamically difficult. Its early migration, if the major model class is on the right track, may have helped deplete and remix the belt while the system was still young. The point is not that one object alone did everything. The point is that a giant nearby changed the rules under which local growth had to operate. Mass belongs inside the same lesson. A rich reservoir can survive more setbacks because it still has something left to feed the leaders. A thin reservoir cannot take many losses before the race changes character entirely. Once depletion, stirring, and later impacts begin reinforcing each other, a region can stay scientifically active while becoming planet poor. Ceres and Vesta make the point easier to feel because they keep the story tied to real bodies instead of floating away into theory. Ceres shows that gravity shaped at least one body into a round world-like form. Vesta shows that early heating and differentiation happened as well. Those are substantial middle stages. The missing step was not the beginning. The missing step was the final local victory in which one object absorbs or dominates most of the rest. That is why the belt is not a story about nothing happening. It is a story about something important happening under conditions that did not stay favorable enough. The distinction matters. A dead region teaches less. A region that almost taught itself into a planet and still failed teaches more. It also changes how we think about uncertainty. In hindsight, a finished planet can look inevitable simply because it exists. The belt shows the earlier truth. Before a planet exists, the outcome is conditional. Bodies can grow, interiors can differentiate, surfaces can survive for billions of years. None of those facts guarantees a finished world in that particular zone. That is the larger rule the belt preserves. Planet formation is not a yes or no switch turned on by the presence of rock. It is a long chain of favorable terms that can be interrupted at more than one stage. The asteroid belt is the place in our own solar system where that interruption stayed visible. The shortest honest answer to our question is that the asteroid belt failed for several linked reasons at once. That is why the region resists slogans. Each clue matters, but no single clue deserves the whole burden. Start with the mass layer, because mass is the first hard correction. The belt we see today is tiny by planetary standards. All the asteroids together do not add up to the Moon. That immediately weakens the idea of a lost, mature world. It also tells us that any later attempt to rebuild a planet would begin from a very poor inventory. Whether the young belt once held more mass is an important historical question. The present ledger alone already says the surviving region is not rich enough to make the myth comfortable. Then add the dynamics layer. Jupiter did not sit nearby as harmless scenery. Its repeated timing carved unstable lanes into the semi-major axis distribution of belt objects. Resonances kept making some orbital neighborhoods harder to inhabit. At the same time, stirred eccentricities and inclinations turned many encounters into worse prospects for accretion. Mass tells us the belt is poor. Dynamics tells us the belt is also difficult. Then add the history layer. The modern belt is not an untouched original stockpile. Major model classes, such as the Grand Tack, suggest a more crowded early system in which giant planet migration could deplete and remix the asteroid reservoir while also helping explain Mars's small mass. The details remain model-dependent. That boundary matters. What does not go away is the broader conclusion that today's belt is the remnant of a more eventful early environment, not a pristine nursery that simply waited too long. Now add the survivor layer. Ceres and Vesta prevent the story from becoming too negative. If the belt contained nothing larger than rubble, we might be tempted to think serious growth never began. Ceres says otherwise. So does Vesta. One is round and dwarf planet scale. The other is differentiated and scarred. Those bodies tell us that the process advanced far enough to produce substantial worlds in miniature. The region did not fail because it never started. It failed because the later steps did not stay open. Then add the collision layer. Once the belt was both depleted and dynamically rough, later impacts mostly revised the survivors, instead of helping one object finish the job. Collisions did not appear out of nowhere at the end as a separate story. They became the late expression of all the earlier damage. A poor belt with excited orbits is exactly the kind of place where collisions are more likely to grind and scatter than to calmly build. If you want to hear those layers as one continuous scene instead of a stack of labels, follow one imagined body through them. Early on, the neighborhood still contains enough solids that growth seems plausible. Repeated encounters let the object gain mass. Perhaps it reaches the scale of an embryo, or at least approaches it. Then the setting changes, supply drops. Resonances keep some lanes unsettled. Relative speeds rise. From that point forward, the body is no longer climbing in a generous nursery. It is trying to survive in a corridor that has become harder to rule. The same place has not stayed the same place. That is also why the layered answer stays honest when the strongest model claims are kept in proportion. Nobody has a recording of Jupiter migrating through the gas disk. Nobody can weigh the primordial belt directly. Yet the direct pages of the archive still push us towards certain conclusions. The region is underweight now when a planet would need abundance. It still carries bodies that plainly grew part way. Its orbital structure keeps pointing back toward Jupiter's long influence. Its scars keep showing that later collisions removed material instead of neatly returning it. Models matter because they try to connect those pages into a history, not because they replace the pages themselves. Put those layers together and a pattern emerges without much forcing. The modern belt is too light for the vanished world picture to feel comfortable. It is also too dynamically rough to sound like a place where one embryo enjoyed an easy late victory. On top of that, the region preserves survivors whose histories make sense as partial successes rather than final rulers. Later impacts then keep writing subtraction onto those survivors instead of healing the deficit. None of those features behave like the old myth's single lost planet. Together they explain far more of what the belt actually looks like. That is the value of a layered answer. It keeps one oversimplification from being replaced by another. Saying Jupiter did it is incomplete. Saying the belt never had enough material is incomplete. Saying collisions ruined everything is incomplete. The region was shaped by a combination of bad terms that reinforced each other. Science often feels strongest when different kinds of evidence agree without being forced. The asteroid belt has that quality. Its tiny mass budget fits a region that never produced one dominant body. Its survivor population fits incomplete accretion. Its orbital structure fits Jupiter's long influence. Its late scars fit a belt that did not recover. The clues are not random facts collected for atmosphere. They are parts of the same argument. There is also a useful discipline in how those layers are known. The present mass is a direct measurement. Ceres and Vesta are direct objects. Kirkwood gaps are directly mapped structure. Early migration and exact primordial inventory are not in the same category. Those belong to reconstruction, tested against the surviving facts. Keeping those levels distinct does not weaken the answer. It strengthens it because it lets the direct observations do the anchoring while the models explain how such an outcome could have been reached. Another way to hear the answer is as a sequence in which the region kept losing advantages. First, the inventory becomes a problem. Then the orbital setting grows more difficult. Then early history seems to thin and remix the reservoir still further. By the time the late collision record dominates, the belt is already living on poor terms. The later ages do not rescue a strong nursery. They preserve the result of a weak one. That sequence matters because it stops us from imagining the wrong fix. If the only problem had been one late impact, then more time might have helped. If the only problem had been present low mass, then perhaps the past would remain open to almost any story. But the evidence does not leave that kind of room. Each layer limits the stories left by the others. A layered answer is not a failure of nerve. It is the proper size of the truth. The belt is complicated because the process that shaped it was complicated. Shortening the answer too aggressively does not make it clearer. It only starts throwing away the very evidence that makes the answer trustworthy. And yet the final direction is simple. A region that looked planet-shaped on a map did not stay rich, calm, or protected enough to produce a finished planet. The details are many. The message is one. After the layered answer settles in, Ceres changes meaning. It stops being a trivia object and becomes one of the belt's clearest witnesses. Its round shape is not a decorative fact. It is evidence that gravity gathered enough material in one place to pull a body past the lumpy stage. Something real was underway there. The region was not condemned to remain gravel from the beginning. That is why Ceres matters so much here. Dawn did not visit a rumor. It visited a mapped world with its own geology, surface-age questions, and evidence of internal complexity. If no body in the belt had grown beyond rubble, we might think the whole zone simply never had a chance. Ceres says the chance was real. Growth reached a serious stage. The puzzle is no longer where the construction began. The puzzle is why it stopped short of a final dominant planet. That makes Ceres valuable in a very specific way. It is not merely large. It is large in a form that gravity had time to shape. The body tells us the early belt was capable of producing enough local success for matter to start behaving like the beginning of a world, rather than the persistence of a rock pile. When that sort of object still ends up stranded inside a plural, depleted population, the map itself starts to look less like a missing planet and more like a stalled threshold. Vesta changes meaning in a complementary way. Vesta is not round like Ceres, but it carries a different sort of authority. Dawn showed a differentiated small world with a violent impact history. Iron core evidence, giant basins, and meteorite links make Vesta a witness to both early achievement and late damage. It is as if the belt preserved a body that learned to become a little world and then spent the rest of its history surviving in the wreckage of a bad neighborhood. Once those two objects are understood, even the smaller asteroids stop reading as anonymous clutter. They start to look like the remaining population of a zone where no final winner absorbed most of the rest. Their plurality is part of the evidence. A finished rocky planet between Mars and Jupiter would have swept up or dominated far more of that local material. The crowd itself tells us that the sweep never happened. That crowd matters physically, not only visually. In a zone where one embryo truly wins, the local ledger ends up concentrated. You expect one obvious ruler and a much poorer supporting cast. The belt preserves the opposite social structure. One large round survivor remains. One differentiated battered survivor remains. Numerous smaller bodies continue on their own tracks. The population still looks like a society of leftovers rather than a kingdom after consolidation, and that social shape is part of the evidence. Dawn made that plurality easier to feel because it turned the largest belt bodies back into places. Ceres gained a face, a surface, and a geology. Vesta gained texture, depth, and visible scars large enough to dominate the whole object. Once those places become vivid, the belt stops sounding like a generic band of leftovers and starts sounding like a neighborhood where specific worlds survived an unfinished history. That neighborhood quality matters because neighborhoods preserve contrast. Ceres does not erase Vesta. Vesta does not erase the smaller families around it. The belt still lets different kinds of objects coexist in view, and that coexistence is part of the map's honesty. A completed planet would simplify the scene. The belt keeps the complexity exposed. That changes the solar system map. A textbook label such as Asteroid belt sounds like a category. A better mental picture shows a record of interrupted concentration, matter gathered part way. Some bodies became remarkable. Then the region stayed plural. The plural structure matters more once you imagine what a completed neighborhood would have looked like. A finished terrestrial planet would not leave behind so many independent biographies at its own address. Most of the useful nearby mass would either be inside that world or dynamically subordinated to it. Instead, we find a region where several kinds of history remain side by side. One object records roundness, another records differentiation and violent excavation. Smaller bodies preserve their own families and trajectories. The map still contains many voices where a completed planet would have turned most of them into one. The word scar starts to feel useful here because a scar is not emptiness. It is a visible result left by a history that changed the final form. The belt is like that. The zone between Mars and Jupiter still carries the mark of what happened there. It does not carry the mark as one obvious broken shell. It carries it as survivor worlds, gaps, reduced mass, and a crowd that never yielded to a single ruler. The survivors also keep the explanation from becoming too negative. Failed formation does not mean nothing meaningful was built. Ceres and Vesta prove that serious work happened before completion failed. The belt preserves both the effort and the limit. That is more informative than a total dead stop would have been. If the region had never produced anything larger than gravel, we would know far less about which stage went wrong. Meteorites sharpen that point because they bring the belt's history into human reach. A stone linked to Vesta is not a symbol. It is part of a differentiated body that formed, cooled, was later struck, and eventually sent fragments outward across the solar system. Those samples remind us that the belt is not a distant philosophical problem. It is a place with recoverable history. Ceres contributes something different. It gives the eye a round object to hold on to, a reminder that the belt is not merely a cemetery of chips. Gravity once shaped matter there into a world-like form. The body does not solve the whole question by itself. It prevents the whole region from being reduced to trivial leftovers. There is also a useful emotional correction in that. The old myth gives the belt importance by inventing one vanished hero. Ceres and Vesta make that extra invention unnecessary. The region already has faces. It already has bodies with enough individuality to carry the story honestly. One grew round. One differentiated and kept the scars. Together they make the belt matter through survival, not through fantasy. That is why the survivors change the map instead of decorating it. They turn the belt from an abstract absence into a place with faces, surfaces, and histories. Once the belt has faces, the lost planet myth loses some of its emotional monopoly. You no longer need to imagine one vanished hero to make the region matter. The surviving witnesses already do that honestly. There is also a deeper lesson in the way those witnesses function. Planetary history is not preserved only in finished triumphs. It is often preserved in partial successes that stopped at revealing middle stages. The asteroid belt asks us to respect those middle stages. They are not disappointments standing in for something more worthy. They are the evidence that makes the larger conclusion possible, and Dawn's visit to Ceres adds one more useful texture to that picture. This is not a guest object blurred into the background. It is a mapped world in the inner solar system, visited by spacecraft, studied as a place with its own geology and surface history. That kind of direct attention makes the belt feel less like a category and more like a neighborhood of actual worlds. So when the map changes, it changes in a very specific direction. The belt becomes a place where growth climbed far enough to leave interpretable bodies, then failed to produce one completed winner. That is a richer picture than the schoolbook band of anonymous rocks, and it is a truer picture than any vanished planet story. At the beginning of this documentary, the space between Mars and Jupiter looked like a gap. Gaps are hard on the imagination because the imagination wants to fill them. Once the evidence is allowed to stay in place, the gap changes character. It becomes an archive. That word fits because the belt stores different kinds of record without forcing them into one form. One page of the archive is a body we can see directly. Ceres gives us that page. Another page is a surface that still carries a wound. Vesta gives us that one. Another page is written in orbital architecture rather than rock. Kirkwood gaps do that work, because an underfilled lane can be just as revealing as a crater when the same timing pattern keeps reappearing. The mass ledger adds a quieter page still. The belt's surviving weight is so small that the number itself becomes evidence. What makes archive such a useful word is that it respects the line between direct observation and reconstruction. The present belt is observable. We can measure the orbits of bodies that remain. We can visit Ceres and Vesta. We can link meteorites to a parent body. Early depletion pathways and migration histories are different. Those have to be reconstructed from models tested against the surviving record. An honest archive can hold direct pages and missing pages at the same time. That mixture does not weaken the archive. It is what real archives are like. This way of seeing the belt also rescues failure from sounding dismissive. A failed experiment that leaves no trace teaches very little. A failed experiment that leaves the apparatus on the table, samples in jars, missing entries in the logbook, and a few clear measurements can teach a great deal. The asteroid belt belongs to the second category. The failure did not erase itself. It stayed in orbit, where later missions and meteorite studies could keep reading it. That makes the region important beyond its own address. Planetary systems do not preserve only their finished successes. Sometimes they preserve interrupted attempts, and interrupted attempts can reveal the rules of growth more clearly than finished planets do. A completed world hides many of the stages that led to it. The belt leaves those stages exposed in partial form. There is an emotional shift hidden in that thought. The belt stops feeling like a disappointing almost. It starts feeling like one of the most revealing neighborhoods in the solar system because the failure remained legible. What first looked empty turns out to be densely informative. The old map of emptiness falls away here. Empty space is not what the belt offers. It offers distributed evidence. You read one part by looking at Ceres. You read another by tracing the contour of Sylvia on Vesta. You read another by plotting where certain resonant lanes stay underfilled. You read another by adding up the surviving mass and hearing how small the total remains. The clues are spread out, but they keep leaning toward the same history. A finished planet between Mars and Jupiter would have been easier to point at, but it would also have hidden the interrupted pathway that came before it. The belt leaves that pathway exposed. It tells us the solar system includes not only places where growth succeeded, but places where success stalled and left notes behind. That distributed quality is also why the region resists lazy storytelling. Lazy storytelling wants one event and one image. The belt wants a pattern. Once the pattern is seen, the clues reinforce each other with unusual discipline. Ceres would mean less without the depleted ledger around it. Vesta's scars would mean less without the rough orbital setting that kept later subtraction alive. The gaps would mean less without Jupiter nearby to explain their rhythm. Each page sharpens the others. The archive idea also leaves proper room for uncertainty. We can measure the present belt directly, but we cannot rewind the young solar system and watch depletion happen in real time. So the early route by which material was removed and remixed remains model dependent. That limitation is not embarrassing. It simply tells us what kind of archive we have. Strong on surviving evidence, incomplete on lost footage. The archive stays sturdy because the surviving pages already point away from an exploded finished planet and toward incomplete formation. It also changes how we think about absence. There is no finished planet between Mars and Jupiter, yet the zone around that missing outcome is full of boundaries that describe what happened. The surviving mass is too small. The population stayed plural. Certain orbital lanes remain underfilled because Jupiter kept pressing on the same rhythm. Absence becomes readable when the surrounding structure is this specific. That is why the belt feels richer the longer you sit with it. An archive rarely gives its meaning away in the first glance. You have to move from page to page, from body to body, from crater to orbit, until the pattern accumulates. The asteroid belt rewards exactly that kind of patience. The more slowly you read it, the less it looks like a blank, and the more it looks like a preserved argument about how difficult finishing a planet really is. Another reason the archive image holds up is that it works at more than one scale. Dawn orbiting Ceres and Vesta gives us close pages, the kind you can almost touch. Meteorites linked to Vesta give us pages that have fallen all the way to Earth. Orbital surveys give us wider pages written across the whole belt. A good archive rarely speaks in one handwriting only, and the asteroid belt does not either. That matters because the archive is persuasive for more than one reason at once. Spacecraft supply close-up pages. Laboratory samples supply tactile pages. Orbital surveys supply system-wide pages. When very different methods keep steering the story toward the same broad conclusion, the conclusion starts to feel less like a preferred interpretation and more like the natural reading of the record. The archive also slows us down in a useful way. If you stand too far back, the belt can still collapse into a generic band of rocks. The moment you read it page by page, that generic picture falls apart. One page tells you a rounded dwarf planet survived. Another tells you a differentiated body was struck hard enough to throw fragments toward Earth. Another tells you Jupiter kept certain lanes uneasy for ages. Another tells you the remaining mass is far too small to flatter the old lost planet story. The archive forces patience, and patience is exactly what the topic needs. It is worth noticing that one of the archive's strongest pages is written in absence, not presence. A missing orbital lane can be as informative as a cratered surface when the missing lane sits exactly where Jupiter's timing should trouble it. That is a strange strength to have. Most stories rely on objects. The belt can rely on missing objects in specific places, and that gives the archive a kind of discipline that simple wreckage stories never achieve. That is different from a ruin. A ruin points backward to one completed thing that later collapsed. An archive points outward to a whole process. The asteroid belt belongs to the second category. It preserves evidence of early growth, later disturbance, repeated impacts, and a reservoir that did not stay generous enough to finish its work. Scientists do not need perfect footage of the young solar system to learn from that. They need enough surviving signals that different reconstructions can be judged against them. The belt provides exactly that sort of stubborn constraint. It does not hand us every answer. It narrows the credible ones. That narrowing function is easy to underestimate, but it is one of the archive's greatest strengths. A good archive does not have to answer every question directly. Sometimes its job is to disqualify the wrong stories. The asteroid belt does that beautifully. It narrows the room for an exploded planet myth. It narrows the room for any account that treats Jupiter as irrelevant. It narrows the room for the idea that late time alone could have repaired the problem. By refusing those easier stories, the archive makes the harder truth easier to hear. That is why the region becomes more satisfying the more patiently you look at it. The map first offered a blank. The evidence turns that blank into notes from an attempt that did not succeed. That is a far more interesting role than emptiness, and a much more truthful one. Return one last time to the map that opened this whole question. On a quick glance, the space between Mars and Jupiter looked like a missing address, as if some ordinary rocky planet should have been standing there. After following the evidence, the same region looks different. It looks like a place where growth crossed several important thresholds and still never reached sovereignty. Ceres became round, Vesta differentiated and survived giant impacts. The belt kept real bodies. What it never kept was the long, favorable run that would let one body absorb or dominate most of the rest. That is why the key word in the answer is finished. Saying the belt failed to become a planet can sound, on a quick hearing, as if nothing much happened. In fact, a great deal happened. Matter gathered. Some objects grew large enough for gravity to change their shape or their interiors. Jupiter's timing kept sculpting the orbital setting. Later collisions kept redistributing what remained. The story is not empty. It is unfinished, and unfinished is a much more specific condition. Once that distinction is heard clearly, the old missing planet question loses its grip. The issue is no longer where the planet went. The issue becomes why completion never stabilized there. The answer gathers naturally from the same bodies and structures we have been following all night. The surviving mass is too meager for a comfortable vanished world story. Jupiter's resonant pressure kept shaping the orbital setting. Early depletion seems to have reduced the room for one local winner to keep feeding. Later collisions then acted on that weakened population in ways that favored subtraction over recovery. You can test that answer against every major witness we have met. Ceres does not behave like a shard from one vanished world. It behaves like a survivor from real but incomplete growth. Vesta does not behave like anonymous rubble either. Its differentiated structure and south polar basin preserve both early success and later damage in one place. Kirkwood gaps do not behave like random scatter from a single blast. They behave like lanes that stayed under Jupiter's repeating influence. The tiny remaining mass refuses, from the start, to look like the comfortable remains of a mature planet. The difference between beginning and finishing deserves a little more respect than it usually gets. Many physical processes can begin under conditions that are only briefly favorable. Finishing is harder. Finishing asks for continued supply, continued dynamical tolerance, and enough time without repeated subtraction for one winner to keep widening the gap. The asteroid belt appears to have been granted the early opening but denied the long, stable stretch. The broad conclusion stays firm even though the first few million years are not preserved as perfect footage. Migration histories remain model-dependent, and exact starting inventories remain model-dependent too. That uncertainty matters, but it does not throw the answer back into confusion. The surviving evidence still tells us what kind of outcome this region records. We are looking at incomplete accretion under difficult terms, not at the aftermath of one finished planet exploding and then somehow vanishing into a belt this small and this structured. That makes the belt more instructive than a completed planet would have been. A finished world hides the middle stages that led to it, because most nearby competitors disappear into the winner. The belt keeps the middle stages visible. Ceres shows one level of survival, Vesta shows another. Smaller asteroids, families, and meteorites preserve additional fragments of the history. The region remains legible precisely because it never completed the usual act of consolidation. There is also a useful humility in that lesson. Planetary systems do not fill every plausible slot with a world just because our diagrams make the slot look convenient. A location can contain rock, time, and real early progress, yet still fail to produce a planet if the neighborhood keeps spoiling the conditions needed for the last steps. Between Mars and Jupiter, the neighborhood never stopped doing that long enough for one winner to take command. That is the turn that permanently changes the map. The asteroid belt is what remains after world-making got far enough to matter and then failed to finish. Once that clicks, the region stops looking like an embarrassing leftover and starts looking honest. It preserves the truth that beginning is easier than finishing, and that the last part of the climb may be the hardest part of all. You can hear that honesty most clearly in the contrast between an embryo and a planet. An embryo only needs to get ahead for a while. A planet has to stay ahead until the neighborhood reorganizes around it. That second demand is harsher. It asks for durability, not just momentum. The belt appears to have produced momentum several times, and durability never once. If one winner had truly crossed that line, the scene between Mars and Jupiter would have acquired a different social order. Most of the local mass would have ended up concentrated around that one ruler, and the surviving caste nearby would feel more like leftovers in its shadow than like independent witnesses with separate biographies. The fact that the belt still reads as a plural population is one more reason it sounds like interrupted ascent rather than failed cleanup after a finished world. Seen from that angle, the inner planets become more interesting too. Earth, Venus, and even small Mars stop looking automatic. They become successful outcomes drawn against a nearby counterexample. The belt does not merely tell us what failed at one address. It throws the rest of the solar system into sharper relief by showing how much cooperation between mass, timing, orbital calm, and long-term stability was required before a finished rocky world could emerge. That is why the belt rewards slow attention. It is not hiding one lost event in the dark. It is displaying the accumulated result of many pressures that kept leaning away from completion. The more patiently you look, the less the gap resembles a blank, and the more it resembles a verdict on how demanding planet formation really is. Imagine if one embryo in the belt had truly broken away from the pack. Its gravity would have started reorganizing the nearby zone more decisively. Local rivals would have been absorbed, scattered, or reduced to minor leftovers. The address between Mars and Jupiter would no longer look plural. That scene never arrives. The population remains a record of interrupted competition rather than completed rule, and that is why the belt still tells its story so openly. So the planet between Mars and Jupiter did not die after the fact. It never completed the act of becoming. The evidence asks us to respect that harder answer because it is written into the survivors, the scars, the missing lanes, and the meager ledger that still circles the Sun today. If you return now to that simple map where we started, the region between Mars and Jupiter no longer looks like an empty slot. It looks like a place with a memory. Mars still circles on the inside. Jupiter still dominates beyond. But the belt between them no longer reads as missing rubble from a ruined world. It reads as interrupted construction that never reached its last stage. That is why the modern belt matters so much. It shows that rocky material by itself is not enough. Time by itself is not enough. Even impressive early growth is not enough. A planet needs a neighborhood that keeps helping one body pull ahead instead of repeatedly undoing the work. Between Mars and Jupiter, that help did not last. Ceres and Vesta make the point tangible. Ceres is round enough to show how far the climb went. Vesta is differentiated and scarred enough to show that real little worlds formed there and still endured enormous damage. The Kirkwood gaps add a quieter but equally strong clue. Jupiter kept shaping the region through timing, not through one spectacular blow. The low total mass adds another clue. The surviving inventory is too small for the old missing planet fantasy to feel physically comfortable, so the belt is better understood as a scar than as a ruin. A ruin suggests a finished structure that later collapsed. A scar suggests a form altered while it was still becoming. The asteroid belt preserves that altered form in plane orbit around the Sun. That conclusion changes the rest of the solar system in return. The planets we do have stop looking automatic. They start looking like successful outcomes among other possible outcomes, including one in which growth began, produced real survivors, and still never crossed the final line. Earth, Venus, even small Mars become more interesting when seen beside the belt, because the contrast shows how much had to cooperate before a finished world could emerge. The asteroid belt failed to become a planet because planet formation is conditional. Growth there was real, but the conditions that would have let one body finish the job did not stay in place. The reservoir was reduced. The orbital setting stayed rough. Later collisions kept editing the survivors instead of consolidating them. The broad answer is firm even where some early details remain model-dependent. That is what makes the belt so revealing. It preserves the opposite of inevitability. It preserves a case where the ingredients were present, the early progress was real, and completion still did not happen. In a sense, the belt is stricter than the planets. The planets show what worked. The belt shows how much had to work together before any planet could exist at all. It is tempting to hear that as a story of frustration, but I do not think frustration is the right final note. The belt is generous in a scientific way. It did not produce a planet, yet it kept the evidence that explains why. Ceres remained, Vesta remained, the resonant structure remained, the low mass remained, even the later debris and meteorite links remained. The answer was never hidden far from us. It was only quieter than the old myth. So the next time that dark band appears on a diagram, it will not look empty. It will look like one of the clearest records we have of how a world can begin, struggle, and still never arrive. Not a ruin after completion, a scar from a process that never got to finish.